So good afternoon, everybody. Thanks for having me today, giving you an overview about Frequentis and our network management solutions, especially with a focus today on the part of the visualization. So what we're doing within Frequentis is various things. We are known, of course, for our voice gateway capabilities, VCS systems, and so forth, but also for the various solutions that we offer for networks. That means we have a wide variety of products, from gateway products, from software products, but also, of course, and that's a very important part, is the visualization part now. That means whatever goes on in a network needs to be seen, needs to be evaluated, and we need to get the information to see what's actually happened within the network. So the solutions that we offered are deployed today at about 60 plus ANSPs in various flavors, and the idea behind the solutions are to also give the customers now the capabilities to grow. Yeah, and one thing is, of course, also now into the pandemic to grow stepwise, not to have major investments, but to show them a path where they can grow the capabilities without investing heavily from the beginning on. So in that area, we are approaching not only the terrestrial networks as we have them here in Europe, and they are very capable of a lot of things. As Peter explained earlier, for example, the remote digital tower solutions, where you need higher bandwidths than you have, for example, in networks that you're supporting in Africa or South America, where they're relying maybe on VSAT technologies. But still, we have to support the applications and make sure that they are transmitted over the network. And what we are doing within Frequentis, when we look into that three-layer model, we have the ANSP, that's the customer with all its applications. On the bottom, we have the network itself, the infrastructure. That can be, as I said, terrestrial. It can still be legacy lines, TDM lines, VSAT lines. And what we do in the middle is we create a middle layer, what we call the ATM layer, that increases the performance of the applications, increases safety and the security level, because we know now what's going on in that network that we have to support, and we're increasing the level of situational awareness. And that becomes even more important now, that we are not having these infrastructures that only belong to the ANSP as it was in the old days. When we look into the VHF, for example, network, we are opening up now, we're sharing capacity, physical lines with other customers as well. And therefore it is even more important when we, for example, look into the area of cybersecurity and how network management systems can be integrated with SOCs that are coming, and even more important now that we know what's happening in our infrastructure. So as I mentioned earlier, for the customers that we are supporting today with the solutions, we want to build a bridge, and very easy, let's say, entry level, where the customer can say, we first of all want to be interested and want to know and monitor certain applications without managing them. That's a big difference, managing the applications and monitoring the application. So we say, dear customer, here's the entry. This is what you get. You get your monitoring capabilities for example, 24/7 operations, yeah, that you know how it is working within your network. Then we go into the real situational awareness, where we put another level on top of it, and by the end you can have then a full-blown network management system with all the capabilities are requested. The focus that we have in the network management system is not the pure managing of certain devices, but on the services that are running over the network. So most of the network management systems today, they focus on a certain device level. Of course, they see what's the bandwidth utilization, how much is the jitter, what is the packet loss for certain applications, but they do not match the application need and the network capabilities at a certain event or time. So what we do is we're measuring these applications on a permanent level. On top, what the ANSPs are struggling with today is that they have a variety of network management systems. They have a VCS system, they have a ground air system to control the VHF radios, they have for the radar systems a network management tool to configure, to change certain parameters at a certain time. And then on top, of course, there's the network management system itself that controls routers, that controls switches, and so forth, and manages and looks into the overall network solution, but it's very complicated. So there's also no correlation between all these systems. You have a VCS that is managed, you have a VHF radio, you have a radar, but there's no correlation in regards to how do they interact with each other. What's the impact on a certain event? And this is what we are doing within Frequentis. We are putting an overlay, an umbrella network management system that manages all the components, but not only the components, we are measuring the services that are behind. So it doesn't help you if you have a network management system that shows all the devices. It's green, it's red, the nice colors that they show would not necessarily tell you if the service is working in the way the controller expects it or the pilot expects it. So from that point of view, we're really focusing, as I said earlier, to interact with all the applications and the network itself to provide the performance that really is required for a certain application. And I'm not talking necessarily about echo or packet loss for radars that could potentially cause black screens. So again, measuring from an end device, and this is as close as possible to the radio and as close as possible to the VCS or the radar device, the ADSB device, to see if the network, if you have redundancy in the network, fulfills the application need. Yeah? And then take measures and actions to enable or give the best performance again towards a particular application. So how do we do that? We are basically introducing a middle layer, what we call the ATM grade layer. And as said earlier, we're looking into the networks. If there's redundancy, some of them, they use also a hybrid infrastructure like terrestrial and satellite networks in parallel. But the performance characteristics of them are very different in regards to delay, bandwidth availability, and so forth. So what Peter explained earlier also for the remote digital tower, in the event that, for example, the network changes or has to change because of an outage or a broken device, we still have to enable the application to also work over, for example, a low bandwidth network. How do we do that? We would, for example, measure the video stream. If we see the bandwidth is not sufficient because of particular settings, we could reduce then, for example, for the remote digital tower video quality. We go from a color mode, we could go to a black and white mode. We could reduce certain frame sizes. So we are really seeing what is the application doing, how is the video stream doing, how is the voice call doing. And if we see the parameters are not fulfilled by that certain network at that certain time, we take actions. And we do the actions before actually the event occurs. So we see that packet loss is increasing, which the router would normally not see, and he would say, okay, I have a timeout from the other side, and would then switch to an alternative path. We do that proactively, so we switch before actually the failure occurs. And then, of course, it's transferring all this information into graphical tools, yeah, that the technicians, the controllers can see, I have an issue on a certain path, for example. So in a full-blown environment, and this is what we have implemented for customers, we have the high-level network management system, so that you do your configuration management of all the devices, the fault management, security management, which is an important part now. We take care on that, also the end of life, to see if devices are still supported by the supplier, if the software is active, or they have to be changed. And then there are certain other elements, like, for example, on the VSAT links, as I mentioned, the quality control. VSAT links, what we see at customers today, if they are getting active, modems have certain characteristics. So they are changing forward error corrections, modulations, and so forth, and that's normally an indicator that the satellite link is not as good as it should be. Maybe bandwidths will be reduced. If we see that change, we are giving the application information about that to maybe look for an alternative path or reduce to a certain size, which is still then acceptable for the pilot and the controller. So we're really, really looking in all the applications, and that's the big difference between a regular network management system, what we are providing. It's not managing on a device level, but on a service level. So we're really measuring and viewing, monitoring the service, not the device. So, as I said, visualization, of course, that's a major part that allows the operators to identify issues on the network. It creates a lot of automation to it. That means not so much intervention by a certain technician is required. So we really automate a lot of these things. We integrate them. And on top of that, we measure them. And that's the main thing. So, for example, what you can see on the very right-hand side, we do also the measurements to the certain applications. For example, we look, are these voice packages, if we talk about a voice stream, is it complying to the ED standard? Is all the information in the header of an IP packet, for example, the radio frequency available? We do mean opinion score measurements. At the old days, it was always controller, VHF radio, and then by the end of the day, is the quality acceptable or not? Multiple controllers were listening into it. They said it's good, and it was always based on a perception. But now we're measuring these links. We see a certain quality of the voice package, and we look if they are complying to the standards that are required, like, for example, an end-to-end service over ED138. Yeah? So, again, that's a big difference from a device monitoring and management towards a service management. So, as said earlier, there's an example for a VHF radio. So what we do is, we have a certain frequency here, 123.5 megahertz. And then we see all the devices from the VCS up to the radio. They are green, they are supporting the service in the way they need. And we can see if there's maybe an issue already. So we have an overall status here on the left-hand side, which is orange. That means a certain element of the link is inactive or is not working anymore. But still the difference is here again, the service view. And we see now the service is working. But what is the big difference? If you would see a regular network management system, you see all the green lights as well. But even though if the VHF radio would show you a green light, getting a feedback or giving feedback to a network management system, you would not know if the radio frequency is correct. That means it could show green. The operator would not be able to talk to the pilot anymore, the controller. But the network operator would say everything is green, it's not my problem, but you would not see if the on-air signal is going out. So we are also measuring not only the device, if it is giving feedback to the network management system, it is potentially active because of a ping that it receives. We're really looking now if the on-air loop gets closed. So does the controller and the pilot, are they able to talk with each other? Which you would not see on a normal network management system. It would show green, that's it. And then we have incorporated all of these measurements and settings not only for voice. You can measure each and every single service. For example, surveillance data, ADSB signals, radar services. Is the radar service duplicated? Can we send it over multiple networks at the same time? Is the service fulfilled? Is the packet loss, for example, too high? Does the controller get the quality he really expects from that service? So the main key thing, and this is the takeaway that I want to give you, is measuring services instead of devices. That will not help by the end of the day to see if the performance of our application is fulfilled. And there we have then introduced certain tools. That's a software tool that we're putting on a device. It can be a router, it can be an appliance. And we do various things. We do the quality monitoring. We see if the quality of the application is fulfilled. Then we do a bandwidth estimator. That means we are looking, is the bandwidth sufficient for that particular application? As said, for example, you're switching a remote digital tower from a terrestrial network where you have 100 megabit or even gigabit links towards a satellite link where you suddenly have only 3 megabit. Then you need to figure out, is the bandwidth sufficient to support the application? If so, we're looking what needs to be done to support that with a flow optimization. And we have certain triggers that says, okay, you can go to an alternative path or not. So we are all looking into the various, let's say, parameters that enable the customer still, even in a very hybrid environment, to use the application even though over narrowband links by measuring and monitoring different factors. And then again, we're looking what I said earlier into the performance of these links. So for example, you can measure then the data links, you can see the VHF links, and it shows you then, is it green, is it red, is it orange? Orange means yes, but there's an issue on the link. Green means yes, it's perfectly working. Red would say, no, it's not working at all. And then you can see, of course, also via the timers, via protocols, when did a certain outage occur, when was the service not performing as it is requested to perform, and so forth. And last but not least, we are looking also into the second part of it, and that's, you have on one side the NOC, the Network Operations Center, and then the integratability into SOCs, into security operation centers. So by measuring all these streams permanently, we have a lot of indicators. If, for example, data traffic is running over the network that is not supposed to run over the network, by measuring it, we see if there's unexpected traffic behaviors. Is there a peak? Is there new information running through the network? Could be via a new device. It could be because we have problems on the links itself. And then we enable the SOC people and the NOC people at the same time by receiving this information to do necessary actions. For example, it could be a faulty interface, but on the other hand, it could also be a cyber attack. Somebody's hacking the network. And we're providing in parallel all that information to everybody, so they get an overview. The SOC people can see if it is important for them or not. On the other hand, the network operations people will see, yeah, there's an issue with a certain device that is not able now to fulfill that service. So at the end, it's an integration of all the capabilities and services into a single platform from an end-to-end perspective. Not only measuring the service, but giving valid information to various people that are involved in the network tasks. As I said, the network operations people or the cyber security people, the SOC people. I hope I could give you a quick overview about the very difference about these network management systems that are out in the market and the network management system that we are provided, which is tailored toward ANSPs. We understand the applications, we're looking into them, and we are measuring on a service view, not on a device level view. So thank you very much. If there's questions, feel free to ask. If not, I wish you a great show and hope you had interesting information and some good takeaways. Thank you very much.